So now we're going to dive into factoring trinomials. So this is going to be where we have a polynomial with 3 terms. And the very first thing we're going to do is look at factoring trinomials where your a is equal to 1. So if we've got a trinomial that's in standard form, and actually let's take off the equal 0. Okay, so if we have ax squared plus bx plus c, and if our a is equal to 1, then this is what we're going to do. We're going to first factor out the GCF, okay? Always your first step. Second, we're going to find 2 integers whose product is AC and whose sum is B. That sounds a little confusing, but you'll get it once we do a few examples. If you can't find any numbers that can be multiplied together and can also be added to equal that B, well, then it is called a prime polynomial and cannot be factored. And then lastly, your goal is to create 2 binomials that are being multiplied together using those factors. All right, so if we start with our first example here, x squared plus 12x plus 32. So right away, we can see that this is in standard form. Our standard form, ax squared plus bx plus c. So if you take and multiply that a times that c, that's where the 1 and the 32 come from. The 1 is in front of that x squared multiplied by that c, which is 32. Our factors of 32, we just brainstorm them, okay? 1 times 32, 2 times 16, 4 times 8. Then once you start repeating them, so the next factors would be 8 times 4, well, then you can stop. You don't need to repeat your list. So the pair of factors 4 times 8 also can be added to equal 12, which is our B term. All right, so now I take those factors 4 and 8, and then you can create 2 binomials using those factors, x plus 4, x plus 8. Okay, so let's go ahead and try some of these examples. I'm going to work down the left. So a squared minus 12a plus 27. First thing I see is that the leading coefficient is a 1. So I'm going to do 1 times 27 equals 27. That is our key term. So we're looking for what can we multiply that gives us 27, but is also going to add up to negative 12. Okay, so you can start with 1. 1 times 27. Then you ask yourself, does 2 divide into 27? Nope, 3 does. 3 times, 3 times 9 is going to give us 27. All right, that 3 and 9, we can go ahead, and if you add those together, you get 12. But I don't need a positive 12. I need a negative 12. So what if I go ahead and make both of those factors negative? A negative times a negative will still get me that positive 27. And if I add them together, then I am going to get my negative 12. So now I can take each of those factors. I'm going to create 2 binomials. I take this a, whatever is squared, and I split it. I put 1 of those variables at the beginning of each of my sets of parentheses. Because my factors are negative, I am going to subtract each of them. I'm done. That is my factored form. Okay? All right, let's do another one. X squared plus 10x minus 24. So I'm going to start the same way. I'm going to go ahead and take 1 times negative 24 gives me negative 24. So I'm looking for what can I multiply that gives me a negative 24, but then adds to a positive 10. Okay, so I can start the same. 1 times 24. Don't worry about the negative just yet. 2 times 12. 3 times 8, 4 times 6. So now I need to go back and I need to think about that negative. So your largest number, your largest factor is going to have the same sign as your B term. So in this case, 10. So that's what's going to be positive. Your other factor will be negative. Okay, so I'm going to go ahead and make all of my small factors negative. When I add across, I'm going to get first a 23, then I get a positive 10. So that means that negative 2 and 12 are going to be the factors that I use in order to create my factored form. So I'm going to go ahead, set up my 2 sets of parentheses, take my x squared and split it. Then I take my negative 2, so I make minus 2. My positive 12 makes plus 12. I'm good. That is factored. Now, for the next one, working our way down, that one has 2 variables, not just 1. So notice I've got a y in here in addition to my x. So not to worry. What you want to do first is you want to ignore the second variable. So if I rewrite this, okay, so I'm going to rewrite this simply as x squared plus 10x minus 24. Oh, that's exactly the problem I just did. Okay, I just did that one up above. So I don't need to redo it. I'm just going to go ahead, copy down my 2 binomials, put in x minus 2, x plus 12. Now, the way that I get my y in is just like we took our x and split it in each of the binomials. Now I'm going to do that same method with the y, except instead of putting it in the front with my front term, I'm going to put it with my back term. So I literally just tack it on. So you might be thinking, seriously, that's all you do? That's all you do. All right, we can check this for sure. Let's go ahead. So you check it by multiplying. So I'm going to take x times x to give me x squared. X times 12y is going to give me 12xy. Then negative 2y times x gives me a negative 2xy. Negative 2y times positive 12y gives me a negative 24y squared. My middle terms can be combined because they're like terms. So I end up with x squared plus 10xy minus 24y squared. That's exactly where we started. All right, so I'm just going to put the answers here for the 3 on the right that you can try on your own. x plus 10, x plus 3, and then we've got w minus 7, w plus 4, and then we have w minus 7z, w plus 4z. So you can practice, see if you can get those answers. All right, now, what happens when our leading coefficient is not a 1? All right, that's what we're going to focus on right now. And this should be right here. That should be a 1. Make that little change in the notes. All right, so again, first thing you do, factor out the GCF. Then we're going to look for our key factor, our AC. All right, just like we were doing before. So we do the same thing. We look for what two numbers can you multiply to get your to get that product that comes from the AC, but whose sum is B. Okay? But then what we're going to do is we are actually going to rewrite the middle term as the sum of the first two terms. So this step right here is called splitting the middle. We're going to split the middle. Okay. And then we group. Okay. So let's go ahead. There's that example there. I'm just going to jump in with number 1, problem number 1 here. So we're going to start by multiplying 12 right here. 12 times -5, which is a -60. So we're looking for what can we multiply that gives us -60, but then adds to our middle term of -17. All right. So I'm thinking of how about a 2 and a 20 look kind of, oops, I'm sorry, that would give me 40. How about a 3 and a 20? And that gives me the 60. I need it to be a -60. My sign of my largest factor needs to match my B. So my 20 is going to be negative. So this gives me 3 plus -20, which is a -17. Okay. So now that I have my factors, 3 and -20, everything so far has been exactly how we were doing it before when our A is 1. Here's where the difference comes in. I am going to split this middle term using those factors. So it'll be a 3x minus 20x. Why the x? Because it needs to add up. Those like terms need to add up to that middle term exactly that has the variable. So I just add the x on. All right, let me bring down my outside term. So the 12x squared, and because that 3x is positive, I put plus, and then I bring down the -5. So now I'm in a position where I have 4 terms. When I have 4 terms, I use grouping. So my third term, I have to be careful. It's subtraction. I want to change it to addition. So that's going to be plus a -20. So I'm going to put parentheses around the first 2 and the second 2 terms. Out of that first grouping, I'm going to take out a 3x, and I'm left with 4x plus 1. Out of the second binomial, I'm going to, because it's negative, it's a -20, I have to take out a negative greatest common factor, so -5. So then I'm left with 4x plus 1. The 4x plus 1 is common to both, And so it's 4x plus 1 times 3x minus 5. There we go. All right, let's do this again. So I'm going to take 8 times 1, which is 8. So I'm looking for what can I multiply that gives me 8, but then it's going to add to 6. All right, that's not too tough. How about 2 and 4? 2 times 4 is 8. 2 plus 4 is 6. So I'm going to use these two factors to split the middle term. So right there, I'm going to split it 2x plus 4x. And because that 2 is positive, I put a plus in front, working backwards, 8x squared. Then I bring down the plus 1. Okay. Now I want to use grouping. So I put parentheses around the first 2 and the second 2 terms. I'm going to continue on, take out a 2x. So I'm left with 4x plus 1. Now this is interesting. I've got a 4x plus 1 and a 4x plus 1 up there, but I have to factor something. But I don't want that second binomial to change. It's exactly how I want it. So I'm actually going to take out a 1. Whoopsie. So if I divide everything in that term by 1, nothing changes. It still stays 4x plus 1. But this plus 1 is critical. So now I've got 4x plus 1 times 2x plus 1. Those are my two binomials. All right. Let's go ahead and do one more. So I've got 6 times negative 7. So I'm going to go ahead, multiply to get negative 42. But then it's going to add to negative 11. All right. So I need to think about what factors are going to work for me. So I start going down, just ignore the negatives for a moment. 1 times 42, 2 times 21. Does 3 go into there? 3 times 14. That's a little suspect. There we go. I think that's going to work for us. Okay. If I make the 14 negative, then I multiply those two factors together to get a negative 42, add them to get a negative 11. That works. So now I want to split the middle term. Okay? So I bring out my 3x and plus a negative 14x. Now I've got to bring down the 6x squared and the minus 7. I'm going to put parentheses around these two, the first 2 and the second 2 terms, so that I can use grouping. I'm going to go ahead and pull out a greatest common factor of 3x, so I'm left with 2x plus 1. Out of that second binomial, I'm going to factor out a negative 7, so then I'm left with 2x plus 1. My final factored form is going to be 2x plus 1 times 3x minus 7. Let's keep going. So number 4 is a little bit different. The 3 previous examples, we haven't had any greatest common factors, but this one we do. notice that 24, 4, and 4 all share a common factor of 4. So here's what I'm going to do. I'm going to rewrite this as 4, and then I'm going to use square brackets. You could use rounded parentheses, doesn't matter. And then I'm going to divide each of these terms by that GCF. So I'm left with 6x squared minus 1x, that I just write as x, minus 1. Finish my square brackets. So now I'm just going to factor the trinomial inside of the square brackets. So I'm going to go ahead and take 6 times -1, which is -6. So I'm looking for what can I multiply that gives me -6, but is going to add to that middle term of -1. I think 3 and 2 might work. If I do a 2 and a 3, making my larger number negative, that will give me my -6. And if I add them, I will also get -1. So I can use those to split my middle term. So I'm going to have here 6x squared plus 2x minus 3x minus 1. Now, I don't want to forget that 4 that I pulled out at the very beginning. So I'm just going to continue to carry it down each row. So now I can go ahead and I can use grouping. Out of that first binomial, I'm going to go ahead and take out a 2x. So I have 2x times 3x plus 1. Out of the second binomial, I'm going to take out a -1. And then I'm left with 3x plus 1. So now I've got 3x plus 1 times 2x minus 1. And I don't want to leave out that 4, which is necessary to be considered our final factored form. If I left out that 4, it would be incorrect. Okay, let's go ahead and try our fifth one, problem or example number 5. So I'm going to go ahead. I look to see if I have any, any greatest common factors. I do not. And so I'm going to go ahead and do 6 times 6, which is 36. So I'm looking for what can I multiply that gives us 36, but is going to add to 37. It's the obvious. 1 times 36. Then that is going to add to 37. Okay, so I'm going to use those factors of 1 and 36 to split my middle term. So that I'll write it down there so you can see that 1 very clearly. 1x plus 36x. Bring down my 6x squared. Bring down my plus 6. I'm going to group the first 2 and the second 2 terms. Out of the first binomial, I remove an x, and I'm left with 6x plus 1. Out of the second binomial, I remove a 6, and I'm left with 6x plus 1. So the final factored form is 6x plus 1, x plus 6. Okay, we're cruising. Let's look at another example. 6s and 5s are sometimes a little bit challenging. So that's why I put this example in here. Let's go ahead and give it a whirl. So I see that my leading coefficient is not a 1. So I'm going to start the same. Okay, 6 times negative 6 is a negative 36. So I'm looking for what can I multiply that gives me a negative 36, but adds to a positive 5. All right, how about 4 and 9? And what if we make the 4 negative? So I'm going to use those to split my middle term. So I've got 6x squared minus 4x plus, oh, I am so sorry about that. Let's get back to where we were. There we go. Okay, plus 9x minus 6. So now we're going to go ahead, group the first two and the second two terms. That we're going to factor out of that first binomial a 2x. And so then we are left with 3x minus 2. Out of the second binomial, we factor out a 3. So we're left with 3x minus 2. So now we've got 3x minus 2, 2x plus 3. That is factored form. Look at number 7. Number 7 is interesting because our leading coefficient is negative. That is never a good thing. So I am going to go ahead and factor out a greatest common factor of -1 just to get us started. So we've got a -1 that comes out. And so then we're left with a positive 6a squared plus 25a plus 25. So now we're looking for, I'm going to multiply 6 times 25, and that'll give me 150. So we're looking for what can we multiply that gives me 150 but adds to 25. All right, so you can, let's see if we did 15 and 10. Always when you've got these big numbers that are multiples of 25, or if they land and they've got a 0 at the end, 10 is oftentimes one of the factors you want to consider. So 15 times 10 gives me 150. You add those, you get 25. Let's go ahead, split the middle term. So I've got 6a squared plus 15a plus 10a plus 25. I want to still bring down that -1. Group inside of the square brackets. So now I can take out of that first binomial, how if we take out a 3a? So then we're left with 2a plus 5. Out of that second binomial, let's take out a 5. So then we're left with 2a plus 5. So now we've got 2a plus 5 times 3a plus 5, and we don't want to leave off that factor of -1. All right, let's keep going here. So this last one, number 8, I'm going to, let me see if that one is interesting. Yeah, it's more of the same. So I'm going to go ahead and just give you the answer here. You should, and you could try it on your own. You should get x minus 3, 5x minus 3. All right, let's keep going here and look at what is called perfect square trinomials. we will be using these so much during the rest of the semester. So I'm going to introduce them now, and we are going to almost every module go over them again, okay? We will be using them in different formats. So what a perfect square trinomial is you start with a trinomial, and the first and the last terms are perfect squares. And so you take the square root of each of those, and that's what is going to become the factors. They're the numbers that you use in your binomial, okay? And it's the same binomial multiplied, and so we actually write it as an exponent. So let's actually just look at one of these, because it's almost easier just to look at. And I think the way it's written here is a little bit confusing. So let's just kind of redo this. 9x squared plus 12x plus 4. Clearly, 9 is a perfect square. 4 is a perfect square. So we're going to create our binomial and put an exponent of 2 outside of that binomial. Now, we're going to take the square root of 9. That's going to be 3. The square root of x squared, x. And then the square root of 4 is 2. Whatever the sign is between the first and the middle term is going to be the sign of your binomial. Now it's done. You do want to do a quick check. If you multiply the two terms together, 3x times 2, and you double it, or in other words, if you multiply that by 2, that's the same thing as doubling it. Then multiply all that together. So 2 times 3 is 6. 6 times 2 is 12. So that gives us 12x. It should always add up to your middle term. Okay? Or I should say multiply out to your middle term. All right. So let's go ahead and factor number 9. First thing we look at is that the first and the last terms are perfect squares. So I can go ahead, create my binomial squared. I take the square root of 25x squared, so that's 5x. I take the square root of 36, which is 6. This sign, the subtraction sign, is between the first and the middle term. So that's the sign that I use in my binomial. It's done. There's no splitting the middle term. There's no looking for factors. That's it. It's a beautiful thing. Okay. Now, most people would look at problem number 10 and they would say, heck no. Too many fractions. Not even going to try. And I would challenge you to say, it's really not that bad. Now look at how I look at it. This first term, that's a perfect square. The square root of 4 is 2. Now for this last term, 1 is a perfect square. The square root of 1 is 1. The square root of 9 is 3. So that means the square root of 1/9 has to be 1/3. That's not so bad. All right, so let's go ahead, create our binomial squared. Started out with a 2x. Our second term in our binomial is a 1/3. How did I get that 1/3 again? If I take the square root of 1, that's where 1 came from. The square root of 9, that's where the 3 came from. That's not so bad. Now, this plus sign goes in your binomial. Well, now let's check this. Okay, so it's going to be 2, that's my formula, times my first term, which is 2x, times my second term, which is 1/3. Well, 2 times 2x, that's just 4x over 3. That's exactly what I have for my middle term. So it checks out. Pretty cool. All right, let's try number 11. Okay, it should be this fast. I see that I have a perfect square with the 36. I have a perfect square with my 49. So I'm going to go ahead, take that binomial, raise it to the second power. Now the square root of 36 is 6, and then it's 6x. And square root of 49 is 7. Take the sign between the first and the middle term, and that's going to be the sign that we use in our binomial. So now you have enough information to do really well.